Hello and welcome to SAS Explorer. Today we are going to showcase a super demo called Leveraging KT Charts with streaming data to improve industrial processes. I am Sergey Peredri. I'm Principal Research Statistician Developer in IoT Division.
And I'm Byron Biggs. I'm a Distinguished Research Statistician Developer also in the IoT Division.
I will briefly introduce you to KT Charts monitoring method, and Byron will do the demo. Why do we need KT Charts? KT Charts is a monitoring technique that can be useful for multiple applications, such as quality control or condition monitoring. It can be used for monitoring multivariate high-frequency data. A good example is sensor data of high-value capital equipment or even a whole plant. So pretty much any machine, equipment, or process that has sensors can be monitored by KT Charts. KT Charts monitoring has several useful features, such as it is easy to set up, the monitoring results are easy to visualize and easy to interpret, and it can provide an early warning for operational faults to enable preventive maintenance before the catastrophic failure occurs. It has a built-in mechanism to minimize false alarms. KT Charts has advantages over traditional quality control charts. First, it is a subgroup control chart. We aggregate data over time to analyze it, which leads to noise reduction compared to monitoring individual observations. And second, we can monitor both drift and volatility or spread of the process. What is KT chart monitoring? As I already mentioned, it is a subgroup control chart for high-frequency multivariate data. It processes a moving window of observations during a specified time period. It is based on a support vector data description, or SVDD. And now very briefly about SVDD. SVDD is an unsupervised machine learning technique for one-class classifications. It builds a mathematical model of data boundary, thus separating data into stable process versus outliers. It does not impose distributional restrictions on data. It has a built-in parameter tuning. It has a flexible data description, and it allows multiple operating modes. KT charts allow monitoring both drift and volatility of the process at the same time. And volatility or drift or spread is measured using a single number. There are two charts produced by the method. R-squared chart for monitoring spread or volatility, and A chart for monitoring drift. The chart terminology stems from SVDD. In the simplest case, SVDD builds a hypersphere boundary around the data with a center A and a radius or threshold R-squared. With flexible data description, the boundary can have a more complex shape to conform to data. In a nutshell, KT charts do SVDD repetitively for a moving window of observations over time so that we can monitor a drift in the center position as well as a spread of the process. In SAS VIA, KT chart monitoring method is implemented first off as a CAS action set. Then, based on that, there are two SAS procedures that are part of SAS visual forecasting. PROC-KT train for training based on the stable data, and PROC-KT monitor for scoring or monitoring based on new incoming data. Moreover, we have implemented streaming KT chart monitoring in SAS event streaming processing, which Byron will demonstrate in a couple of minutes. Before we jump to the demo, let me tell you quickly about the data. So the data that we used is so-called Tennessee-Eastman process. The Tennessee-Eastman process is a realistic model of a typical chemical industrial process that consists of five main process units: a two-phase reactor, where an exothermic reaction occurs, a liquid vapor separator, a stripper, a compressor, and a mixer. This is another open loop, unstable process that is widely used in the academic community as a case study of multivariate statistical process control, plant-wide control, and the sensor fault detection. The process has 41 variables that are sensor readings, and the simulation code can generate the stable process as well as 19 different faults. With KT chart monitoring method, we were able to identify the onset of all 19 faults using either the R-squared or the A chart. On this slide, you see the training charts generated by PROC-KT train. Originally, the sensor readings happen every 5 to 10 seconds. We have expanded data to have 20 readings per second. 108,000 observations or 90 minutes of stable data were used for training. The window size is set to 1000 or 50 seconds. And this is pretty much the only parameter that you have to set. The training determines the center and the control limits for both charts, and these results are later used for monitoring. On the top left, you see the training A chart, which shows the behavior of the process center. And on the bottom left, you can see the R-squared chart that shows the process spread volatility over time during stable period. Here you can see the monitoring results for one of the faults, fault 13, using ProcKT Monitor. What we did here is we fed all the monitoring data at once into the Proc. As you can see, the A chart clearly shows that the process center started drifting outside the upper control limit, and the monitoring was able to identify that well ahead of time before the actual failure occurred at the end. And now Byron will show you the demo.
So we have a deployment of SAS Viya in Microsoft Azure, and we're going to show you the process end to end. We're going to show you the training procedure using the normal data in SAS Viya, and then we'll stream the fault data through SAS Event Stream Processing at a high data rate, high frequency data, to show you how we can detect a fault in near real time. And now let's check out the demo. Here we are in SAS Studio. To save time, I've already uploaded the sensor data that we're going to use for training our KT chart model. I'll open that data set to show you the contents. So we have a time column and a column for each of the 41 sensor values that Sergey mentioned previously. These are industrial process sensors. We have 20 readings per second in this data set for a total of 108,000 rows. This represents about 90 minutes of data. So we're going to run the KT train proc on that data. Important inputs are the data set that we're going to use. We specify a window size. So a window size of 1,000 with 108,000 rows means we're going to run 108 SVDDs on this data to generate our KT chart model. We have the 41 sensor values as the inputs, the time value as the time, and a number of statements so that we can save the results of our model for later use during scoring. One to note is a save state, where we're going to save the model file that we're going to use for SAS Event Stream Processing that I will describe in a minute. So let's run that training. And what it's doing, like I said, it's running 108 SVDDs, each on 1,000 points, representing 108 windows in the data. And it's looking at the spread in the data and the centers of each of those SVDD clusters and generating control limits based on those values. At the bottom, we see the R-squared chart for the training data, and the data is essentially all within the control limits that we've generated. We look at the statistics of the spreads to generate the upper and lower control limits. And the top chart is the A chart that represents the 108 centers of the SVDD clusters. And we've used that to generate upper and lower control limits as well that we'll use for scoring. Now we've saved this model file that we're going to use in SAS ESP. So we'll use ProcAstore to download that from SAS Viya so that it's available to us in SAS ESP. I'll run that step quickly. And I'll show in a second how we use that. So I've also uploaded the data for one of the faults. This is like recorded data for one of the faults on the plant that we're going to use to demonstrate the monitoring process. When we run ProcKT Monitor to score that data, we have the data set again, the information that we saved previously from the training step that represents the KT chart model, and we'll run that. And again, what that's doing is doing an SVDD on each window of 1,000 points in the fault data using all 41 sensors and looking at the centers at the top and the spread in those clusters. And it's about 50, I believe 54 clusters in this fault data. So if we look at the R-squared chart at the bottom, we see that the R-squared values are within the upper and lower control limits essentially. But if we look at the center, we see that as time goes on, the center is drifting away from the limit, from the center that we generated in the training step earlier. And so we've pretty clearly identified a fault in this data as time passes. So let's switch to SAS event stream processing. SAS event stream processing is SAS's streaming analytics framework that allows for the high-frequency analysis of streaming Internet of Things data to generate real-time insights. So for our demo here, I've built a simple model in SAS Event Stream Processing Studio. The first window is a source window. You can think of this as the window that will ingest the 41 sensor values from the factory data. And the contents are very simple. We have a time field and the 41 sensor values, as I mentioned earlier. And those values feed into the KT chart scoring window. The important parameter to note here is the scoring info reference. So we're letting the KT chart scoring window know the location of the model file that we previously saved and downloaded during the KT train procedure in SAS Viya. So what we're going to do here is stream the values in. This is a simulation, and I'm going to run that simulation at 20 times normal speed. So we had 20 readings per second. So I'm going to run 20 times that speed. So we're going to have 400 readings per second, just so the demo will run a bit faster. And as those values come in, we're going to score them in KT chart monitoring to try to detect faults that may occur. And so now we switch to SAS Event Stream Manager. What I've done is I've created a ESP server deployment in the cluster. And in that cluster, I'm going to load and start the model that I previously published from SAS Event Stream Processing Studio. And as I do that, I'm going to also look at a dashboard that I've created in SAS Event Stream Processing Stream Viewer that will monitor the data as it flows through the system. So at the top we have the A chart and the upper control limit. At the bottom we have the R squared chart and the upper and lower control limits. So as the data comes through, each data point that appears represents an SVDD analysis of 1,000 data points that produced a center and a spread for that cluster, and we're comparing that with the center of centers in the A chart and the upper and lower control limits in the R squared chart that we previously generated from the training data. And we see at the beginning we're within the control limits essentially, and as time progresses, we see the center is drifting away, going above the upper control limit. And this indicates that we've identified a fault. At the bottom, again, as we saw in the KT monitor output, we see that the spread is remaining within the upper and lower control limits pretty well, but the center is pretty clearly drifting outside. And remember, this is running at 20 times normal speed, so we're at 400 readings per second, and as in the world of SAS Event Stream Processing, that's still not a very high data rate. SAS Event Stream Processing has an extremely high data rate capability, and we can produce these alerts in near real time with high frequency data sets. And so as the chart runs, we see we're still generating more points, and we've identified a fault. We could easily add an automated alert to this model to generate a real-time alert to some operator who might take corrective action on this process. In conclusion, we've described an innovative control chart method and how it can be used for near real-time alerting with high-frequency data. Thank you for watching our super demo. If you have any questions, don't hesitate to contact either Sergey or me.
If you would like to learn more about KT charts, we encourage you to look at this conference publication about KT charts method and this SAS tech report that describes KT charts monitoring method and its application to several real-world and simulated data sets.